Good morning, everyone, and thank you for being here. And thank you for the organizers for inviting me here, because it's a real pleasure. And I appreciate all of your talks, so that's a very interesting event. So I'm representing an academic consortium located in Paris, which is called Project Sensor City. It's a project for sensors prototyping and validation in realistic conditions. These sensors, they are not any sensors, it's sensors dedicated to sustainable cities. So what am I actually talking about? Sensor City is a suite of equipment at the beginning. It's sponsored by the French government. And there are some of this equipment are equipment for high-level prototyping of new sensing devices, advanced sensing solutions, especially based on micro and nanotechnologies. So you have systems such as atomic layer deposition, you have high-resolution inkjet printing technologies, you have wafer bonding systems, you have basically packaging and prototyping equipment. And you have, on the other end, you have validation technologies. If you develop nanosensors, it's not very easy to prove that it works. And so we also have equipment dedicated to sensors validation, such as an environmental chamber, infrared camera, sorption equipment. Among this validation equipment, the very large part of the project is what we call a climatic mini-city. What is this mini-city? It's a 400 square meter climatic chamber with a climatic pit. What's the use of this thing? It's what people may call urban mesocosm. So it's the ability to model small city neighborhood in a climatic environment. People in the past day have talked about living urban living labs. So you can test your sensor networks in actual environment, in the cities. What we propose here is to have a controlled environment which enables you to test sensor networks in a controlled environment. So at scale 1 or scale 1/3, for instance. And you can test actual scenarios of what is going to happen in an actual city. But you don't have people walking by and tearing away your sensors. You don't have rain when you don't want to get rain, or you can get rain exactly when you want to get rain. And you can see if your sensor, if your communication protocol can withstand actual difficulties. But with some reproducibility, you can have some reproducibility in your experiment. So that's an intermediate stage to test sensor solution and to test models and to test protocols of communication. So these facilities, I don't know about the US, but in Europe it's a unique facilities which is being designed and will be built in the next few years. It should be available in 2 years, basically. It's a unique facilities in Europe because, contrary to standard facilities, it's not only above ground system. It's not only a house, a single house, or maybe a car. It's also underground networks that you can test in there because you have these underground facilities here. So here, you can test underground, and it's large enough for you to test model of condominium system or maybe a lake, a few vegetation, stuff like this. So it's a realistic urban test site. What do we do with this? So let me tell you a little bit more about how we work, what we are doing, based on an example of energy efficiency. So what we work with are commercially available sensors, or also sensors that we may be designing ourselves for specific needs or for advanced sensing capabilities. So we developed this sensors network, and we combine them with advanced modeling techniques, such as inverse method to assess parameters. And we developed HMI, human-machine interface, to transfer the data to the user in a convivial manner. And this enables us to get interesting information on energy performances. So let me give you a bit more details. We've heard talks about controlling AC in houses. What we do is putting sensors that will give you an idea of your thermal situation in a house, so that your sensor system can control automatically AC system, so that you don't have to think about what will improve my bill, but your bill will be improved automatically based on your sensor system. And this you need not only sensor system and communicating system in your house, you also need numerical method that will tell you what will be the temperature, because you can improve your bill if you don't warm up your house, but it's not going to be of any use to you. So you need to be able to still keep a comfort for yourself and your family. So you need sensors. You need to understand what will be the temperature in your house. You need to understand how the sun outside is going to impact your house. Because if you have glass, for instance, if you have huge glass sides in your building, it's going to warm up very easily, maybe uncomfortably so. And you need to predict your bills, and you need to be able to tell it to your user, you need to know about this. So all of these strategies, these are things we are implementing currently. Why is it resilience related? It's resilience to increased energy costs, to increasing energy costs. Based on such a system, you can really imagine, and we're proving that you can definitely improve energy bills. You can devise renovation strategies. The idea being, if you need to renovate a condominium, for instance, that would be really nice to make them LEED certified. Problem is, to this day, you can assess performances of materials, like panels and so on. You have 300% error in the actual current assessment method of building performances. So if you have accurate technologies, you can really expect to get better structures, better buildings, and better quality of life. So another example here, you know that with AC system, you shouldn't open your windows. That's basically the idea. If you open your windows, you lose any benefits of AC. However, what happens is your inner air, the air outside your houses, gets polluted. You've got formaldehyde, for instance. You've got lots of polluting agents, and you don't want these agents. So you need to manage ventilation strategies. But if you want to drive this, to manage properly these ventilation strategies, you need to know what's the pollution level of your atmosphere. And to do this, basically, you need this kind of system. It's a 1 cubic meter system, which costs probably thousands of euros. I don't know in dollars, but you know it's not practically usable in your system. What we're doing within our project is turning this cubic meter system into a credit card size system. And basically for maybe 1 million, 100 of a price, maybe for 50 euros, you get this kind of system. So you see, you can't do anything about ventilation strategies with this kind of huge chromatograph. With this, you can really expect to impact people's life and to improve resilience to this really huge energy cost. So That's really promising for the future. We are also working on water networks. The idea is we are putting sensors into water networks, and we are reconstructing flows in the water network using sensor data. We use it to detect drink water contamination, and we can use it also to manage purification strategies. So basic idea being, if you know that you have a too high chloride concentration, but your water quality is okay, you can decrease your chloride concentration, and your water is going to taste better without any problem for you. So for this, here again, you need sensors, you need numerical model, and you need to be able to let your network manager understand what you're doing, understand your results so that they can apply it to your network. So that's basically our strategy. We're working also on road infrastructure. There are thousands of kilometers of roads that are getting really old and older every day. In Europe, in France, most of them dates back from World War II, the end of World War II. And bridges are getting really old and getting past their lifetime. And we need to be able to monitor the structure, even with a heavy traffic there. So we are developing embedded sensors that we put into the road, into the transportation infrastructure. And we are developing web links that enable us to send this data to the network manager, to the highway manager, so that they can get an idea of what is happening on the infrastructure, and so that they can determine if they have to renovate their road, if to determine what they should do about the road. So let me finish with this. You see, all these applications have a lot of maybe marketable in the future. And they all will contribute to the smart cities idea, to the smart cities concept. So what I want to finish with is to say, you cannot only develop software solution. You cannot only develop data mining. You also need the hardware, the sensor that will measure your data. Because without these measurement capabilities, you don't have data to work with. So that's the combined approach we want to support. And all these systems, they are suitable for both slowly increasing stress. So you see, energy costs are increasing slowly, but it's also suitable for catastrophic events if you adapt your software, if you adapt your sensor to this kind of system. So it's both long-term and short-term solution. So thank you for your attention.